I'm going to give Georgiana a little bit more time to come on, and then we'll get started. Let me check the email here. Right. Hmm. Okay, well, we'll go ahead and start with introducing Kathy. Kathy, can you give us, first of all, let me give you an introduction since for you, this is your first time in our course here. I'm an instructor there at Cabrillo that I've been teaching since about 2001 and been teaching Cisco, Microsoft, security, etc., as well as at other locations in the Monterey Bay area. And this class is designed to prepare people to take the CCNA exam. So it's really designed to be a review course. And we'd like people to have some background in computer networking for this to really work for you. So, and there's Georgiana. Great, good to see her. So Kathy, maybe you could give us a little introduction as to your background in Cisco networking.
I, I'm actually part of the Cisco pre-apprenticeship cohort. I started that in August. Can you hear me?
Okay, a Cisco pre-apprenticeship
Apprenticeship cohort. So yeah.
And
so I've taken classes from NetAcad. I've taken the intro to networking, the switching and routing, and the third one, which now I forget the title, but I've done all of them. So right now I'm preparing to take my CCNA.
Okay. And where did you take those courses?
It's self-study with Cisco.
You did a self-study
with Cisco, but then the introduction to networking, I took it in fall with Rick Graziani.
Rick Graziani, yes.
Yeah, but my background, I've got a computer science degree, which I got it like many years ago. I've been a stay-at-home mom for the past couple of years, so I'm just trying to get back into the industry. So through Cisco, Cisco is kind of helping me get into the industry.
Okay, so your background, you've got the experience of the courses, the class with Rick, and then you're a member of the cohort.
Yes.
And what does the cohort actually engage in? What does it do at this point?
At this point, we are going through the NetAcad classes. And then once at the end of the three courses, you're supposed to get, just hold on, sorry. Can you stop making noise?
Pardon, I didn't quite get that.
With the cohort, we are studying to get the CCNA.
Right.
Then once you get to the CCNA, you get accepted to the apprenticeship program, which is
I
like
got you.
6 months, and then hopefully get employed by Cisco as
I see. Well, that,
yeah,
oh, that sounds like a nice track.
yeah.
That's really nice. And so have you completed the routing and switching and
Yes.
yeah, you have completed that. Okay.
Yeah.
Now I sent you a list of topics that we've covered so far. Now we haven't covered all of them in great depth because we're trying to do some review. Do you have any questions about the topics that I sent you as far as the ones that we've covered?
What I was not quite clear on was whether you've done subnetting.
Okay, so we have not done much in the way of subnetting.
Okay, because I'm
What we
struggling with the subnetting and access lists.
Okay, well, we're gonna go over access lists tonight. Um, and yes, so let me read to everybody what I was recalling that we've covered so far. And if anybody has any questions on these, I've got actually the email I sent to her up here. So these are the topics that we've touched on to some degree or another, some of them much more than others, but the first one is basic OSI and TCP/IP model and operation. Basic IP addressing, so we understand the concept of an IP address and a mask. We haven't talked about subnetting in great detail, at least not any, not the hard part of subnetting. We've done the easy part of subnetting, where you subnet at a classful boundary. Basic router and switch configuration, so setting the host name, setting passwords, so forth. DHCP, how to configure for telnet, basically. How a router operates and what routing is. So what does a router do and what is routing in general? We've covered OSPF routing, single area, access control lists, and some basic switching and trunking. So this evening, what I want to do is start by reviewing access control lists, and I'm going to bring up some slides. So the first question would be, does anybody have any questions about access control lists or actually anything that we've covered up to this point? Is there anything out of that list or anything else that we've covered that you'd like me to review at this point? Are we good to keep going? Okay. All right. So with access control lists, what we have is the use of a wildcard mask. And so what I'm going to do, I'm going to share my screen over here. And go through this. All right. Let's go here. So what we're going to look at is what are access control lists and how can we use them, both standard and extended IP access lists, and how can we apply access control lists to control terminal access with the access class command, and then a little touched on verifying and monitoring. Okay. So the first thing to think of when you get into access lists is not filtering necessarily, but that you want to identify traffic that you want to give special treatment, as it says there. So an access control list itself is simply to identify traffic that you want to treat differently than some other traffic. And one of those things that you might do with that is filter traffic passing through a router, filter traffic going to the Telnet Management Console, determine traffic to be translated or tunneled. So those are all different things that you might do. And here we have some other examples. So when we set up queuing, priority and custom queuing, we won't do that in this class. But when we set up queuing, we can use access control lists to determine how the queuing would operate. We also can use access control lists to trigger dial-on-demand routing. So what would happen is the router would have a potential link to another router with a dial-up connection, but you don't want the dial-up connection to be there all the time. So what you do is you have traffic that comes to the router that would go over that link, and then the access control list would then identify that traffic that would cause the dial-on-demand route to be brought up. And we also can simply filter not traffic coming through the router, but routing table information coming in or going out. So those are uses of access control lists that are beyond just filtering. And we know that we have an access list. Essentially, a standard is only going to check the source address, and therefore, as a result, permits or denies entire protocol suites. Extended checks source and destination address, as well as specific protocols. Okay. We apply access lists when we're filtering traffic. We apply them either inbound or outbound. And here they're showing an example of an outbound access control list. A packet comes into the routing table, and the routing table chooses which interface it will go out. And then it determines, is there an access list on that interface? And if so, then you have to process that packet through the access control list. And in processing the packet, you're going to go through a series of access control list statements. They're called ACEs, actually, access control entries. Here we go on. How we're going to do this is if it passes the statements and permitted, gets sent out. If it's not permitted, it gets discarded. It's going to go through a series of tests, and this is just simply diagramming that. If you match the first test, the question is it a deny or a permit? And you do one of those two things. If you don't pass the first test, or don't match, I should say, on the first test, you go to the next. As soon as there is a match, you do whatever that match requires, either deny or permit. And at that point, there's no further processing of the packet in the access control list. I think that's the same. If no match, we want to note that. If no match, deny all. So there is an implicit deny all in every access control list. Therefore, for an access control list to have any effect, there must be at least one permit statement in it. One statement that if you match on it, there's going to be a permit. Otherwise, it just denies all. Here's the rule you want to keep in mind. One access list per interface, per protocol, per direction. So if I have an IP access list, I can apply it on one interface in one direction and the same interface in a different direction. And I go to another interface, I can apply the same access control list for one direction and one for the other direction. So that's very important, and that would probably be on the CCNA exam, that little phrase right there. Access control lists statements control the testing, and therefore you generally want to put the more restrictive statements at the top. Okay. And you generally want to create the access list before applying to the interface. When you apply the access control list to the interface without having the access control list created, at that point, all traffic is still allowed through. But as soon as you create the first statement in the access control list, then that access control list begins to take effect. So if your first statement wasn't a permit, effectively, when you create the first statement, if it's deny, at that point, you shut down the interface. And also you should note, access control lists filter traffic only going through the router. They don't apply to traffic going out of the router that started or was originated in that router. To build an access list, in this case, we're looking at basically a standard access list number, permit or deny, and then the conditions. Very straightforward. Okay. To apply that to an interface, we say which protocol, and then access group, number, and then the direction. So we'll see here an example of that shortly here. We've got a little table to help us keep these straight to a degree. So we have standard and extended access lists for IP, and these are the number ranges that you would want to keep in mind. There are number ranges beyond that. I would ignore the IPX. I wouldn't bother memorizing that for the exam. And there are other extended and standard IP access list numbers you can use. You should know those for the exam, but right off the bat, you want to make sure that you know what's right there in that box there. Standard access list 1 through 99, and the default wildcard mask is 0000. So when we create this access list, number, permitter, deny, and source, we don't have to put in a mask. We can leave it off. And what would happen then is that default mask would apply. And what does that default mask mean? What first of all, that's a wildcard mask. And what does that wildcard mask mean sitting there? Anybody want to take a guess? Okay. That means that host specifically. Okay. So that is an exact match on that host ID. We recall last week that I built access lists in a text editor is what I did. And the first line you want to have when you use that method is no access list and then the number, so that when you pour the access list back into the router, it wipes out the previous access list instead of simply adds all these statements that you created onto the access list that is existing in the router. Okay. And here is the what we talked about as far as applying it to the interface. And again, no IP access group number to remove it. Okay, so here's a very simple access list. It has one permit in it, and it is saying permit hosts on the 172.16.00, and over here, because it's 00.255.255, any source address that starts 172.16 would be permitted. Okay. And here's how we would apply that if we were applying it there onto a router that had those interfaces. You won't see those interfaces out there now. Okay. And if you want to deny a specific host, here we go, access list 1 deny. And of course, we have that address with a specific mask. And then what you're going to do is have to have a permit in it. In this case, it is a permit any 0000 with the wildcard mask of all 255s can be replaced with the keyword any. In this case, we see the use of the keyword and then how to apply that. Okay, For the VTY, we can apply it to the actual VTY sessions themselves and not have to put the access list on an interface. That's much more preferable and also simpler conceptually. And to do that, we simply are going to apply it to the VTY ports 0 through 4. Generally, we only need to use a standard access list to do this. To get into that mode, we go line VTY and then the range and then access class and the number in or out. Very straightforward configuration there. And here's an example. Access list 12 permit that particular subnet in this case, so 192.89.55.0 with the wildcard mask of 255. The end, that means that anybody from that subnet will be allowed to access lines VTY 0, 1, 2, 3, and 4. So access class 12 in. Okay, the little summary there. And then we have extended access lists. In this case, we're denying FTP traffic, and FTP traffic will come in over port either 20 or 21. Does anybody remember what port 21 and what port 20 are used for? What the distinction is? Okay, you want to know that. Port 20 is for data, port 21 is for control. And what I mean by control is setting up, logging in, etc., giving commands to your FTP server. Port 20 is used for the actual transfer of the data. And that can cause some problems in firewalls because you've got two different ports there that have to be dealt with. And here's an example of this. We're denying traffic from the 170, okay, from 172.16.4.0, any subnet, going to the 172.16.3.0 subnet, where the destination port, now how do I know it's the destination port? Because this is the destination address in that particular statement, and the port follows that. If, on the other hand, I wanted it to be the source port, I would put the EQ space number right after the source address. So that's how you know that that's a destination port that it's going to be looking at. In this case, it's not going to bother looking at the source port. And then to get our permit any, we have to go from anywhere to anywhere. So it's any. To apply this, it's IP access group, again, the number, and then the direction. Okay, and if we're going to deny only telnet, telnet is port 23, and you should know these ports. You should know port 20, 21, 22, 23, and 25. You should know those ports explicitly, and 80 as well. There's some other ports that it's nice to know, actually, as you use these statements more and more, you'll get used to these different port numbers. And here's an example of denying from that subnet to anywhere equals 23. Okay. So this would not permit anybody to go out of the network if that was applied on the whatever interface it's applied, which direction it's applied E0, it would not allow anybody over here to send out here a telnet request. And here they're showing how that would be applied. You also have named access lists. You should know the syntax for named access lists and know that you also can then remove a specific line from a named access list, because what you do is when you put in the IP access list and tell it which type in the name and enter, at that point, you are in the named access list mode configuration or configuration mode. At that point, you can then add statements or with a no in front of it, take out statements. You can't do that with numbered lists. Okay. If you're using the numbers as we did before, okay? And all of this is basically an extension of what we just talked about there. Come up here. This is, again, review. So something you'll want to know for the test is just what is on this slide. Place extended access list close to the source, standard access list close to the destination. Whoops, this one's in a loop, it looks like. There we go, got it out of that. All right. And to verify, we have the show IP int E0, and it will show us that in this right in here, access lists are applied or not. We have an outgoing not applied, inbound applied. And we can show the actual access lists themselves, show access list, the number, show IP or the protocol access list, the number, etc. All right. Any questions on that? All right. Now, I'm not going to go to VLAN trunking protocol next. That's not the one I want to switch to. First, though, before we go into CDP, did anybody have any problem applying the access lists at the end of last week? I think we had you folks do that as a lab. Anybody have any problem with that, or was it straightforward? Anybody have any questions about it? Okay, so everything's fine there. Okay. All right, we have some couple of things we want to touch on here before we go into switching. CDP and Telnet. We've already covered Telnet really to a degree, so this will primarily be on CDP. Cisco Discovery Protocol. So Cisco Discovery Protocol operates primarily at layer 2. So it's a data link proprietary protocol that provides information from one device to another for directly connected Cisco switches. Now, it sends CDP to a multicast address. And because it sends to a multicast address, an address reserved for CDP, when a Cisco switch receives that, it actually absorbs it and processes that particular multicast packet. Otherwise, what normally happens with a multicast packet when it arrives at a switch is it gets flooded as an unknown address. Okay, so how does CDP operate? Let's say I am on a terminal connection to this switch right here. And if CDP is running between these switches and between the switch and the router, then what I can see is directly connected neighbors. In other words, if I can do a show CDP neighbors here, I will see these devices. I will not see that device there. Okay. That's because the CDP packets are being sent from these devices to this device, and this device is not passing them through, but absorbing and processing them. What is CDP going to tell me? It's going to give me a lot of information, as we see here in this list. Yeah. So if I do a show CDP, again, I'm at the privilege exec prompt, I have options. I can do a show CDP entry and look at a particular neighbor. I can do a show CDP interface, show CDP neighbors, and traffic, etc. So you should know these options here. Also, if I want to turn off CDP on the entire device, it's no CDP run. But if I want to turn it off on an interface, it's no CDP enable. Okay. Now, why would I want to turn off CDP? The problem with CDP is that, here, I see, I just noticed I have a chat here. Oh, I'm sorry. I didn't see that chat earlier, Kathy. Let me circle back to that after I do CDP, okay?
Okay, thanks.
Yeah. But I generally, I often don't see chat messages come up because I'm looking up at the screen. So you can, let me know. But that, I'll go back over that. Okay. So here we can see how to turn off CDP. And the reason that we do is that when we're running CDP, we're not only receiving CDP information from our neighbors, but we're also advertising CDP to our neighbors. And if our neighbors happen to be hackers or black hats, something like that, then we're giving them information about our network, and we don't want to do that. So generally, the rule is you would never run CDP on a device on an interface that faces the internet. You would never run CDP there. Whether you run CDP within your own environment is, again, up to you, and a choice that will be based upon whether you want to use that method. There are other methods to discover what's going on in your network, but if you'd want to use that method to have information, it's very good for troubleshooting. To have CDP, you just go show CDP neighbor, and you can test connectivity. You can see what who your neighbors are. If one's missing, then that gives you an idea of a connection that might be down, etc. So CDP is primarily for troubleshooting. So here's an example. I'm on router A, and I'm going to do a show CDP neighbors. The capability codes here are always displayed, and it's just telling us what the table of how to interpret what we see down below. So router B, let's see, I'm on router A. Oh, I see router B. The interface, my local interface, is serial 0. That's the interface that I'm receiving the information on. The hold time is 148. Now, CDP is sent every 60 seconds, and it times out after 3. So what should happen is, if my hold time is 180 or less, it should keep dropping until it gets to 120. At that point, I should receive another CDP packet from my neighbor, and then I would reset the hold timer to 180. And I just keep doing that. If I don't receive a packet, then that timer is going to keep running down until it gets to 0. Then I consider that neighbor no longer there. Now, what does router B have in the way of capability? It is a router, okay, based upon our little table up here. Specifically, it's a 2522 router, and the information being sent from that router is coming out its port serial 1. So the port ID for this device is that one, and that's something they will test you on with tricky questions as to what this is telling you. When you get this information, what does it tell you about other devices? And then we have switch A coming in on Ethernet 0, hold time setting to that, and it is what? A transparent bridge and a switch. And that's just the way they describe it. Transparent bridge and switch are very similar devices, basically. they operate primarily the same way. It's a 1900, and the port ID on the switch is port 2. So understand this, show CDP neighbors. If I do a show CDP entry star, now I'm going to get all of my neighbors, but for each one, I'm also going to get IP addressing information. So you can see that if we have a hacker out there that is using CDP, or we're using CDP and the hacker intercepts our messages, they're getting IP address information from our devices. So that's why it poses a security risk. Show CDP traffic only tells us what's been happening, output, input packets. Show CDP interface lets us see what's going on with various interfaces out there. Okay. Now we have used Telnet before, and I think we showed you. One thing you want to know about Telnet here, this is an interesting little bit of information that could be on a test and also could be useful to you out there. And it is also the reason why you sometimes have your command line hang up on you as it's trying to do a DNS search. So here's what's going on. I'm at the privilege exec prompt. To telnet to a device, I have a number of options. One, I can go telnet and then space the IP address of the device to which I would like to telnet. And it will then try and telnet to that device. No lookup is required. I also could go telnet and then put in the host name, and it's going to look in my local host table. And then if configured, it will do a DNS lookup as well. So if it doesn't find the host name that I'm trying to telnet to, it will then try and do a DNS lookup. And if it not configured to use DNS, which by default it's not, then it's going to simply have to wait until it times out on that DNS lookup, because it'll just do a broadcast DNS lookup. It won't actually have a DNS server configured. So that's a couple options: telnet to the IP address and telnet to the host name. The other two options are leave off the command telnet. If I type in an IP address and press enter, the router assumes that what I wanted to do was telnet to that address, and it will try and do that. Of course, if it can't do that, it'll hang up, and again, your prompt is basically locked out. And the same thing, I can just put in a host name. And because I could put in a host name without the command telnet, if I mistype a command, the router doesn't look at that and say, oh, they mistyped a command. What the router says is, oh, they're trying to telnet to a host by that name. Of course, if you've mistyped a command, there isn't a host with that name. And again, it will sit there and just lock your, spin and spin, and you're locked out until it times out. Okay. So there's 4 ways to telnet at the command line from to a different device. You should know all 4 ways. Okay. When I do a show session, this is for review, I will see where I'm telnetted to. The asterisk shows the current session. And so if I press enter, it will automatically try and take me back to that. If I want to resume this session up here, I have to type resume space 1. To see who is telnetted to me, I can do a show user. Again, these are things you'll want to know in the real world, and also you'd want to know them for the test. Let me just see here. There we go. Now, how do I suspend a telnet session. So I'm telnetted into a different device, and I'm at the different devices command line. What I want to do is suspend that, come back to my own router. So I'm on router A. I'm telnetted to router B. So that's why router B shows there as the host name. Control Shift 6 or Shift Control 6, whatever. These three are pressed down simultaneously, released, and then X. That will suspend the session. If I do a show sessions, I see I still have that session. And if I want to resume that session, I could just press enter or do a resume one. So a lot of potential questions right here in this slide. Did someone once ask for my slides in this group? Did anybody ask for my slides in this group? Anybody remember? Okay. Because you have access to all of the Network Academy materials, but my slides are not within those materials. And I use these slides because I like the way that they set things out a little better than some of the Academy slides. So
Yeah, I had asked for them.
Armando, you did. Okay, so
Yeah.
let me, if you can send me a reminder email, either sometime this evening, then that'll help me, and I'll go and get those out to you. Okay.
For sure. Thank you.
All right. To close a telnet session, well, we want to close. We're on router A, and we want to close a session we have to somebody else. We can do a disconnect. If we want to close a session of someone who's telnetted to us, we do a clear line, and we have to know what line number to put in. Okay. So do you want to keep those distinct in your mind? You should also know about the ping and trace route commands. And you should also know about the extended ping command. And the extended ping command, you type in ping and press enter, and then it prompts you for various parameters. And it's very useful for certain types of testing. But if you just want to do a basic ping the IP address. If you just want to do a basic trace, it's trace to the IP address. Okay. I'm going to go back there, access remote devices. Nope, I want to go there. Access this. There we go. Okay. So I want to go back over this permit versus deny. I had a question on it. So let's go. I'll pick it up about right here. I think this will help. Okay. So we have an inbound packet. It comes in through an interface. It may have already been subjected to an access control list. That's not important to us right now. The fact is, in this scenario, what's happening is it's going to be allowed to be routed, possibly. So we have this packet that's come in. We look at the destination IP address, and we look in our routing table to see if we have a routing table entry for that particular destination IP address. If we don't have a routing table entry, then that particular packet is discarded. And we may send an ICMP message back to the source. But in any case, with no routing table entry, we can't route the packet, and therefore we throw it away, put it into the bit bucket, okay? But if we do have a routing table entry, that will be associated with some interface, some outgoing interface. And so we look at that interface and say, is there an access list applied outbound on that interface? If there's no access list applied on the outbound interface, of course, we simply send the packet out. Boom, it goes out. But if there is an access list, then we have to test the access list statements against the parameters in the packet. If we get a match on a permit before we get a deny, then we will forward the packet with the permit. If, on the other hand, we were to get a deny first, we would match on the packet, but it would be denied. It would then go into the bit bucket. So that would show us here. So if we have a permit, yes, we route the packet out the interface that the packet is supposed to go out. If we get a deny, it goes into the bit bucket. Okay. And of course, down here, what they're saying basically is you have the implicit deny in every access list. So if a packet that is being tested against an access list has no match on any statement in the access list, the effect is to deny it because of the implicit deny. Does that help a little bit there with the processing? That's
Yes.
okay. That's basically what's
Thank
going on. Okay. All right. Let's go ahead and take a break now. We've got about 12 minutes before 7. Let's take a 12-minute break. We'll come back, and at that point, we will pick up on switching. Okay? So I'm going to pause the recording. I think I am going to pause. There we go. Trying to. So I'll see you folks at 7 o'clock. I get this thing. There we go. That off to one side. All right, so we're going to look at implementing VLANs and trunks. We're basically looking at switching. Do we understand how, we recall how switches work? Everybody recall the basics of how a switch works. We can go over that for a moment if you like. In fact, what I could do, if you'd like, let me check here. I've got, let's see, switching. Let me just check something here. This is very simple. I just want to check my own slides whether. Okay, no, I'll go. Okay. So switches work on layer 2 addresses, layer 2 Ethernet addresses. Okay. And they forward based upon destination MAC address. And they learn from the source MAC address. That's how they build their table. Okay, their switching table or bridge table. Now, by default, all ports in a switch are in VLAN 1. So what is a VLAN? A VLAN is an ability to segregate the ports in a switch so that they're not all in the same VLAN. And a VLAN is what? A VLAN is generally a broadcast domain. And what do we mean by broadcast domain? Anybody have any recollection of what that means in the world of Ethernet? That's really what we're talking about, is in the world of Ethernet. Okay, so Well, let's go back to, let's do a little review of Ethernet addressing here. How many bits is an Ethernet address? Anybody give me an answer on that? Anybody? No?
Four
How many
times
bits? Huh?
4 times 8?
Yeah, so it's actually 48 bits total.
Oh, 48.
48 bits total. So there's 6 groups of 8. Okay. And we normally see Ethernet addresses configured with hex. Now, I think we covered hex addressing in the very start of the class. I think I did. But one hex character represents 4 bits. So 2 hex characters represents 8 bits. And so if you're trying to represent 48 bits, you have 2, 4, 6, 8, 10, 12. You have 12 hex characters. That's what you would end up with.
Are we talking about IP version 6?
No. We're talking about switches, layer 2.
Well, you said Ethernet address is 48.
Ethernet addresses. Ethernet operates at layer 2. IP operates at layer 3. Okay. So if we have a frame, what the frame will have in it at the frame header will be a destination and source Ethernet address. Deeper into the frame will be the IP addressing information, but switches don't look at IP addressing.
Oh, then IP address is not the same as Ethernet address.
No, it is not.
Okay.
Yeah. So every card has an Ethernet address on it. Every network interface card has what's called a physical address, Ethernet address. Boy, I tell you, this is when I just really wish I could easily bring up a whiteboard. Well, I'm going to bring up a whiteboard, even though let's see how I'm going to get this thing. Here we go. Thought I had a way to open up a whiteboard easily over here. Hey, but I'm going to stop my share. And now we'll see if I can open up a whiteboard. Okay, not up there. There we go.
Put a whiteboard right next to you and turn around and write on it.
I've actually done that in classes. Let me close this. Oh, there we go. It's where it says whiteboards. There we go. That would be a good place to find whiteboards, is where it says whiteboards. It shouldn't be that tough, huh? God. Okay. All right. So, what was that? What I'm going to do, can everybody see this whiteboard now?
Yes.
Okay. Okay, good. What I'm going to do is draw an Ethernet frame. And then I'm include in it the IP header. But for right now, I'm going to draw an Ethernet frame. Let's just first of all just put a box up there. Nice big box. Let's just do that. Okay. And then I'm going to put some text in that box. Okay, so actually let's do it this way. Put in some text. So much easier than a real whiteboard. Let me get my keyboard out. Okay, so we start off with the destination MAC address. Okay. Next, that's going to be a header. And so then we'll put that's going to be a field in the header. Now I'm going to put some more in there. Let's go draw another line. And draw another line, okay. So what I'm gonna be drawing here is an Ethernet frame, but there are 4 frame types. So what I'm drawing right now is Ethernet underscore Ethernet underscore 2 is the frame type that I'm drawing, just so you know. Then we have source MAC. Grab that little thing in there. There we go. Okay, source MAC. Okay. And then we have the type field. Okay. And this frame is going in, let's just help it out here. An arrow. It's going in that direction. So the reason why I put the arrow up there is that the frame is moving like this. The receiver is receiving it and reading destination MAC, then source MAC, and type field, okay? Now, what do these 3 fields mean? Where do they come from? So the destination MAC is the Ethernet address to which I'm sending this entire frame, okay? Source MAC is my Ethernet card, and it's my MAC address, and that's the one that it's coming from. The type field is where it's handed to next. What protocol does it go to next? And normally, this is going to be an IP packet, so the type field value would be 0800. So there's 16 bits here represented in hex. So let's do this. I'm not going to represent all 48 bits here, but if I did an abbreviated of it down here, let's say that my destination MAC address was just 0A. Okay, let me get some light here on my keyboard. Okay. Source MAC was 0B. And the type value would be often, not always, 0800. And what does that mean? That actually means that what you'll find next is the IP field. So the IP header starts back here. So we would have the, now again, I'm put this out of order, but normally it goes source IP address, then destination IP address. But for our purposes, let's just have it make sense here. When you actually read the destination IP, and then we have just a line there. And then you have source IP. I don't know why that couldn't come out. And then the rest of the IP header. And then after the IP header, what you're going to have is you're going to have, we probably would just say, etc., all of your data back here, which would include whatever other protocols are involved with this thing. So, okay, there we go. All right, so this is what a frame is going to basically look like. But I get that to go like that. There we go. Hard to draw with the mouse on in this surface I'm on. Okay, so when a switch receives this, the first thing the switch does is looks in the destination MAC address field and looks then in its own bridge table, its own forwarding table, and says, do I find that destination MAC address in my forwarding table? And if so, then I'm going to send this frame untouched out that destination interface. If I don't find it in my MAC address table, then I'm going to flood it out all other interfaces. Does this make sense? Okay, hope so. All right. At the same time that I'm doing it, well, as I'm doing this, I determine where do I send it. I'm looking at the source MAC, and I'm going to build my MAC address table from this source MAC field. So all a switch is going to look at are these two fields with an Ethernet _2 frame type. Since Ethernet switches don't process the destination or source IP addresses, they don't need to look at the type field. Doesn't matter what's carried back here. This is IPX, IP, AppleTalk, what wouldn't matter. The switch is only concerned with these two fields right there. Okay. By the way, at the end, there is a frame check sequence. Mouse is not there. We go. That's not there. That's not some. This thing is weird the way it behaves. Anyway, and that's going to be its own separate little thing. So just so you have sort of an idea, this is a basic depiction of a frame. Okay. So when we're talking about switching, we're talking about what's happening right here in this part of the frame. Destination MAC, source MAC. Source MAC will always be a unicast address. Destination MAC could be one of three. It could be a unicast, it could be a multicast, or it could be a broadcast. Okay. All right, so I'm going to close this down. Close whiteboard. All right, and go back to sharing my screen. Hopefully that helped. So when we're talking about implementing VLANs and trunks, what we're looking at is layer 2 operation on Ethernet addresses only. So let's say we've got a network out here that has all these switches in it, and we don't have any VLAN set up. You know, everybody's in VLAN 1, so it's all one big network, one big broadcast domain. See that right there, broadcast domain. A VLAN is a broadcast domain. There's going to be a lot of unknown addresses. That's going to be true. And there's also going to be multicast traffic that's going to get forwarded because multicast addresses and broadcast addresses are considered unknown addresses, and they get flooded out all other interfaces. So what we want to do, instead of having this one huge network with all this traffic going on, all these broadcasts, et cetera, we want to divide it up. And the way that we do it is on a given switch, instead of having the entire switch be composed of one broadcast domain, we divide it into VLANs. So each VLAN is its own broadcast domain. So here you see that on the 3rd floor of this building, we have a switch. This switch has a VLAN that supports sales, a VLAN that supports HR, and a VLAN that supports engineering. So if there is a broadcast in any one of these VLANs, it will not go into the other VLANs. A VLAN equals a broadcast domain, and usually, this is not a have to, but it generally is what's going to happen. It also will equal a subnet. Okay, so normally a VLAN equals a broadcast domain equals a subnet. That would be a pretty good rule. VLANs are broadcast domains. That's not something that is a sometimes thing, it's an always thing. But by design, you also normally make a VLAN a separate subnet. If you don't, you run into all sorts of, issues. You've got really have to know what you're doing and why you're doing it to do something like that. And it's, so we would say generally it's just not done. Okay, so normally that's what you're gonna have. Now, why do we have VLANs? Well, we're able to have segmentation. So in this case, HR can be isolated from the sales VLAN. And for traffic to go from sales to HR, it has to go through a router, because you have to go from one subnet to another, you have to go through a router. And what can we put on routers? We can put access control lists. So right away, we're able to invoke both segmentation, which means we're going to isolate some of the traffic, the broadcast traffic and the unicast traffic. And we're also going to invoke security. And this gives us a lot of flexibility. So now we can have people on the third floor in the sales department, HR, and engineering. We don't have to make sure that only one of those three is up here on that floor. We can actually have them scattered about, and we simply do it by way of VLANs, determine which traffic goes where. So VLANs are a critical aspect of networking. Okay, so that right there at the bottom is gold. Okay. So VLANs don't happen automatically. By default, there's only one VLAN. So if there was only one VLAN for your entire environment, it's as though there are no VLANs, because at that point there's no segmentation going on. Okay. So you're going to create VLANs, and when you do, you're beginning to design your network environment. And why are you trying to create these VLANs? It could be for a combination of things, and we see here you've got management, troubleshooting, error, and sort of fault domain isolation, routing table control, etc. So the reason why we build subnets is because we're trying to achieve all these things. And when we put it on a switch, we have the switch operate in that environment. We call those VLANs. Okay. So now you may notice this looks somewhat like the scenario that I've sent out before. And I know, Catherine, you haven't seen the scenario, the big scenario. I didn't want to send it to you right off because it's a little daunting. I didn't know what your background was, and I didn't want you to look at the scenario and then quit the class. Everybody else, is staying on by way of, coercion, but I didn't have a chance to invoke that yet. So, but we'll see that scenario, and you see that what we've got is, in this case, I've got, let's say, a building here, okay, and I've got two routers. These are actually multi-layer switches, is what they're implying there with that particular symbol. Multi-layer switch is a switch that does both layer 2 and layer 3. And the reason why they have two of them is for redundancy. We'll get to that later, but for right now, it's just for redundancy purposes. Then they have switches within that environment, and you notice that it's a separate subnet down here. So we have the access layer, the distribution layer, and the core layer, if you remember that model that we had before. Same thing over here. So we can replicate these modules as much as we want, really, within a given environment. So here we have the sales is a different subnet, 10.2 instead of 10.1. Finance, a different subnet, 10.3. So we have one IP subnet per VLAN. That's usual as far as design goes. And we want to allocate IP addresses in contiguous blocks normally. Okay, so again, that's just for ease of management and for routing table maintenance and basically efficiency, routing table efficiency. Okay. So let's look at what's going on here. why are we doing this? What are some benefits and what type of traffic are we going to see inside of our environment? Well, there's going to be network management traffic. And it turns out that this list right here is sort of in the order of importance, okay? So when you get into queuing and basically trying to, I should say, quality of service, QoS, and what you're going to do is set up your devices so that network management traffic always gets the highest priority. Telephony would get the next, multicast then next, then normal data, and all S goes into what they call the scavenger class. So basically that's your collection of whatever else you might have not known about or not worried about, okay? So this happens to be in the order of priority for quality of service traffic implementations, okay? So in this case, they're looking at a server farm here. So that's like we had in our scenario, we have a server environment in one building. We have a department here, another department down here, and each of them has the two layers, access layer, distribution, access layer, distribution, and then the core connects to them all together. On top of this, we have the ability, as we said, to create VLANs, but we also have the ability to create voice VLANs. And voice VLANs are an exception to the rule that a port, unless it's a trunk, a port only can be in one VLAN. So let's imagine what's going on here. Let's say that I've got, this is a workstation. The workstation has an IP phone attached to it, and the way that it's cabled, you have a cable going from here to the phone, and then from the phone to the switch. Now, we have traffic that's going to come off the phone that's going to be telephony traffic. We want to give that a high priority. We have traffic coming off the computer that is going to be primarily data traffic, or maybe multicast traffic, but we want to give that a lower priority. Since we want to give traffic coming into this port up here different priorities based upon its source, what we are allowed to do, this is done in software, we can create what's called a voice VLAN, and we give the voice VLAN its own ID, and the regular VLAN its ID. And then we have to have a way to differentiate between the traffic that's coming in here. Is it voice or is it data? Okay, and so we'll look at how we do this with voice VLANs. But I mean, the configuration of it is fairly simple, but the concept of it involves some more understanding here. So let's look at what's going on. Okay, so normally, when we have VLANs between switches, in order to efficiently cable the environment, we don't want to have a separate cable for every VLAN. What we want to do is have one high-speed, often what they call an uplink, but one high-speed link between the two switches that carries multiple VLAN traffic. So whereas this particular link is in one VLAN, and actually it's in with the voice VLAN and data VLAN, and this is in a different data VLAN. Across this link, we're carrying multiple VLAN traffic. Well, how do we know which traffic is what? What we'll see is we're going to tag the traffic with a different frame type. So notice that in the frame that I depicted, there was nothing in that frame to identify what the VLAN was. Okay. So we're going to have to use a different frame type across that trunk. Okay, so now we're sort of jumping. This is something that we'll talk, I'll explain it, and then we'll get back to the concept. It's really sort of, we've diverted from the concept we're trying to explore here. Okay. So here's what you would want to understand. For the most part, in this world, you're going to go to a switch and put each port in a VLAN. And that will be configured by you manually, therefore it will be a static VLAN, okay? So when you say on this switch, FA0/1 is in VLAN 5, whatever I connect out here, it doesn't matter what I connect. I can put in my laptop, I can put in my PC, bring my neighbor's PC. Anybody that I connect on that cable, that one cable, is in VLAN 5, and that's that. All traffic coming across that link and going to the switch is then associated as being with VLAN 5. A wrinkle on that would be what we just talked about, the voice VLAN. So now I've got a cable connected, in this case, they're using a different port, FA03, and I want to be able to distinguish between the voice traffic and the data traffic. So I'm going to assign two different VLANs to that one port. Effectively, you might say it's a trunk port, but it's actually, we don't look at it quite that way. But we just, for the terminology purposes, we're just saying we're going to add a voice VLAN onto that port. So now traffic coming up here will either be put into VLAN 55 for the voice or VLAN 15 for data, depending upon how we've configured that. Okay. Okay, so these are the two normal situations. There's something called dynamic VLAN membership, okay? And this needs to be configured by you. And the reason that you would do it, there are some situations where it actually can be somewhat valuable, but it's not implemented much, is that let's say you've got a machine, let's say this is your laptop and you are a supervisor and you want to wander around the building and plug in your laptop and still be in the same VLAN. Every time you plug in your laptop, you are going to be in the same VLAN. So then what we do is we have a port, in this case, FA02. On this port, we tell the switch that what you're going to do is when a PC plugs in to this port, you're going to look at the MAC address on the PC. And there we see there's the MAC address. Happens to be all ones. Okay. And you're going to then look up that MAC address in a VLAN membership policy server. That's a little TFTP server, basically, is what it is, Trivial File Transport Protocol server. And that particular little server has a database in it that says, if it's that MAC address, it belongs in VLAN 10. So therefore, put the port that this guy connects into at VLAN 10. So that's a dynamic VLAN. In other words, wherever you go, anytime you plug into a port, that port is configured to look up your MAC address and determine what VLAN you belong in. Okay? So that's a possibility, but it's very subtle configured. So let's get back to what we were trying to do earlier. Earlier, we were saying traffic coming on this link here was going to be some of it be data and someone's going to be voice. How can we tell? Okay, well, let's go skip down to this one. We do so with 802.1q frame types. And when we create a link between two switches that uses 802.1q, we call that a trunk. But up here, what we can do is this. We can have the data coming off of the IP phone encapsulated in 802.1q, which carries a VLAN ID tag. Now we know that that is in the voice VLAN. We also know that if it doesn't carry that tag, it's in the data VLAN. So let's look at this down here. So here's an 802.1q frame. Notice that we started off, they're showing you up here. This is the original frame that I drew for you. Destination address, source address, and type. Don't worry about all that LE type. It's just the type field, and then your data. This is what I showed you before for this is an Ethernet _2. But if I am going to send out a frame, and in that frame, I want to put in the VLAN ID, I use an 802.1 queue. This is an 802.1 queue. And I insert what's called the tag field. But the tag field actually consists of the Ethernet type, a priority field, don't worry, a little token ring flag there, and then my VLAN ID. So I use these bits back here to give you the VLAN ID. So this is what's going to carry the information that tells the receiver what VLAN this frame belongs to. Because what happens is the receiver reads this destination. Oh, that's just the destination address. Source, that's the source address. And then it goes to the type. Oh, 8100. Oh, 8100 means that what I'm going to see next here is these fields here, priority, token ring, and my VLAN ID. And then we'll read that and handle it accordingly. So 802.1 queue. Now, when we have a trunk, there's something called the native VLAN. In the Cisco environment, by default, the native VLAN is VLAN 1. It does not have to be. We talked about that. But here's the key. The native VLAN is untagged. Or another way of putting it is that when I send a frame in the native VLAN, I send it in the Ethernet _2 frame type, and the receiver says, ah, that's an Ethernet _2 frame, therefore it belongs to the native VLAN, whatever that is. And we just want to make sure that the native VLAN on each end is the same. Otherwise, if I sent it and my native VLAN was 2 and the others was 1, I would send VLAN 2 information untagged and it would think that it's in VLAN 1. We don't want that. Okay. Now, there is a feature that Cisco has, and I say feature somewhat dubiously because this is also a security nightmare. I can truthfully say that when I was teaching out in the Cisco environment, I was teaching a class, I think it was back in New Jersey one time. And there was a fellow in the class, it was like a 5-day class, I think it was. He was in the class because his network got shut down for 2 days because of VTP. And I just had to, shake my head and wonder because, wow, that's possible. And when we understand how VTP works, we can see the security problems that it has, and there are ways to sort of eliminate VTP if you want, as far as having this security possibility. But here's the idea. Every switch in a VTP domain, they're all put in the domain by giving the same domain name. Every switch in the domain will want to synchronize its VLAN database. So let's just say for purposes right now, we've got 2 different possibilities. We've got switches as clients and a switch here that's a server, VTP server. On the server, I can add or delete a VLAN. So let's say I add a VLAN on the VTP server in the ICND domain. What then happens is this server is going to advertise a version number of the VLAN, of the VTP database, I should say. Advertise a version number. So I have version number 6 for the VTP, the VLAN database. Okay. Well, when he says, I've got version number 6 to all these guys out here, each of them looks at their own version number. And in this case, if everything was working, let's say they all have version number 5. A VLAN is added up here. That makes this version number 6. He says, I've got version number 6. And they all request his VLAN database. Now, they all get the VLAN database and replace their VLAN database with this VLAN database. And now all of the switches are in sync. Well, you can see the advantage. I'm trying to manage all 5 of these switches. I want to add a VLAN. Do I have to go to every single switch and add the VLAN? Well, that's problematic. First of all, it takes time. The other thing is I might misspell it or change the spelling or whatever in the VLAN name, etc. So if I add a VLAN on the server and VTP is running properly and it's configured properly, then my VTP server is going to send out the revision number of the database, and all of these other devices, be them clients or servers, doesn't matter, and for this purpose, they're all going to request my VLAN database if the version number that I sent out is higher than what they have. Okay? So does this make sense so far? The distinction between a VLAN, a VTP client, and a VTP server is pretty simple. On a client, I cannot add or delete VLANs. So I can't make any changes down here at the client. If I'm going to add anything to my VLAN database, I have to do it on the VTP server and it gets propagated out. Okay? Now there's actually an additional mode besides server and client. There's also transparent. And notice that transparent does not synchronize. That's important. But what you would want to design in your network depends upon your network, your policies, security, etc. Because here's the situation. If I've got a server and client environment, I have to make all my changes here, and they all get automatically propagated out there. And these clients don't have to have anything done to them as far as getting their VLAN database updated. Now, to assign ports on the client to a VLAN, I have to actually manage the client either remotely or direct connection. But I don't have to add the VLANs on every single client. Well, this has some security risks to it. So sometimes what people will do is just put every switch in a transparent mode. And that means that I have to go to every switch and create or modify or delete the VLANs as I want. And none of the switches will synchronize with each other. Therefore, I have to do that on every single switch. It's more secure in one sense, but it's more burdensome from a management standpoint. It also will forward advertisements. So let's say there wasn't a link here. Server sends out an advertisement to the transparent server. Transparent server says, well, you've got whatever database number, that's fine. I don't synchronize, but I am going to send it over here. And now the client can say, wait, hold it, I don't have that database, and send the request back up. And so you can get synchronization between the server and client through a transparent switch, but the transparent switch will not synchronize. So what are we going to do to set this up, and how does it work? So we're going to set up our server, and when we add a VLAN, it's going to change the revision number, and it will then advertise the new revision number. I said version number, it's revision number. And the client, if they have a lower revision number, they will request the higher revision number database. Advertisements are normally sent every 5 minutes or when there's a change. So you'd want to know this right there. there's something called VTP pruning. Well, what you can do, and this is, again, something that operates automatically, is let's say I've got switch 1 down here with VLAN 1 and 2, but there's also VLAN 3 in the overall environment. We have trunks configured between these switches. Trunks carry broadcast traffic. So let's say that VLAN 3 sends out a broadcast. The broadcast is put into an Ethernet, into an 802.1q frame with a tag, goes across that link. Normally, because this trunk link is carrying all VLANs, normally that broadcast would then be sent down here. But there are no VLANs on this switch in VLAN 3, so there's no point in the broadcast coming down there. So therefore, switch 1 will send up a prune message to switch 5 and say, I don't have any VLAN 3. Don't send me any broadcast traffic. That's VTP pruning. Okay, so what do? We're going to configure VTP. We're going to configure trunks. We've already done that last week when we configured 802.1q trunks. We're going to create, modify our VLANs on the server, assign ports to each VLAN, and of course, then continue to manage it. Here are your defaults. Okay. And you want to play around with this a little bit because there's some things that are sort of weird. If a new switch comes on, it can actually become part of a domain automatically. Okay. And here you have some of the things that you would set up. So the first thing that we can do is create a VTP domain. Very easy. We say VTP mode, and we say what mode this is in. And then we say VTP domain and the domain name. If we want more security, we go VTP password and password, but we do not have to have a password. Then we turn on VTP pruning if we want that to be operational, and end. We now have VTP operating on our switch. Here we see we set the VTP domain to ICND, VTP mode to transparent, and show VTP status. Now that's a command you'd want to know, showing you the version number, the revision number. This is the version of VTP. This is the revision number of the database, etc., and all this other information here, the mode, domain name, pruning in this case disabled. Okay, don't worry about VTP v2 or traps generated. Don't worry about that. All right, so VTP operates over trunks, VTP trunking protocol. So we're going to create trunks. We're going to create 802.1q trunks. And what we can do is we can use Ether channel to group trunk ports. We actually can use it on non-trunk ports too. But here's the idea with Ether channel. As I add links, there's a protocol that will actually shut down one end of each link as I add links. To have them working properly, what I do is I put all the trunk links into an Ether channel group. We're going to cover Ether channel later. We're going to cover spanning tree protocol, which is what relates to that. And then you'll understand what this would be about. Right now, they're just letting you know that that's the way you get around the spanning tree problems. Okay. So here we go. How to configure a switch port as a trunk. Switch port mode, access, which means it's not trunking, or trunk, which means it is. You can have these other options here, dynamic, auto, and desirable. You might want to know them for the test, but you do not want to generally use them out in the real world. In the real world, you either make every port an access port, or if you want it to be a trunk, you make it a trunk. Those are the commands that you would want to use. Show int interface switchboard or trunk. And we've done that before. You can see what the trunking is, the mode and all that. So here we say show int FA011 trunk. You can just do show int trunk. It'll show you all your trunks. Mode is desirable. What we prefer to have is mode, actually trunk. Encapsulation. Status, it is trunking, and the native VLAN in this one is 1. It's not been changed. The default native VLAN in Cisco is 1. All right, we want to know that CDP and VTP advertisements are sent over VLAN 1. Okay. To add a VLAN, we did this earlier, last couple weeks. VLAN number, that puts us into VLAN configuration mode, and then we can give it a name. Show VLAN, and then we have other options on that, but we've done that before, just show VLAN. And once we're at the interface, we assign the interface to a VLAN with the switch port access VLAN number. Okay. I think that pretty well wraps us up. Show VLAN brief. You've got other commands here, show interfaces. And there's a lot that goes with each one of these, but essentially, these are your basic show commands for monitoring purposes. And this is review here. So one thing you want to know, this is where one of your security issues is right here. When you delete a VLAN, any ports in that VLAN are not moved to an active VLAN by default, and they will therefore be disabled and be unable to communicate. That's why the guy's network got shut down. What he did is he deleted a VLAN that was in use on the network. And the thing is, he didn't realize he was doing that. He might not have done it, someone else might have done it. But in any case, he went to a switch, and I don't know exactly how this story unfolded, but basically on a switch that was not connected to the network, he was playing around and he deleted all the VLANs and then hooked it up to the switch that was connected to the network. And because he'd been playing with it, he had a high revision number. And with the high revision number, his VLAN database, which had no VLANs in it, was sent out to all the other switches. All the other switches lost all their VLANs, and therefore all the ports that were assigned to those VLANs shut down. So that's the security problem that you have potentially with this. Okay, a lot of fun. All right. Now, I think that's probably, we can do a review next week using the other slides, but that pretty well covers that. Now let's bring up the scenario. Okay, so I'm going to stop this share. Share screen. Okay, so what we have now is the scenario that I sent out this afternoon. And, oh, I sent this out for actually purposes of practicing access control list. I thought we'd like to do quick practice on that, but let me send out another one here real quick. Let's take a break and I'll send out a basic switch the one that you've already got it, but I'll send out again so that we get it unconfigured. Let's do a break until 8 o'clock. And then in that time, I will send you out the other scenario, and we'll do a little practice on creating VLANs and trunks. Okay. So. Okay. All right. I know what let's do. Let's try something here. Let's see if I can get away with it. I think I remember I can do this, but okay. Now, let's just see if I think I would just share my screen. Okay, so let me ask you if this works, because I think this is a workaround that I could have been using, and I wasn't sure that I hadn't done this in a while. So let's do this. Do you folks now also see switch 1?
Yes.
Okay. You see the switch 1 config, and you see the switch 1 CLI, right?
Right.
Okay. So now I don't have to stop my share and start it again. This will let me do that. Okay, so I'm on switch 1. And I'm going to go into the enable mode. So I'm now in the privileged exec mode. I'm going to do a show VLAN. And let's see what I've got. I only have, so this right now has one VLAN. These VLANs here are default, and we don't have to worry about them. So just ignore them. We have the one VLAN that's the default VLAN, and all ports should be in VLAN 1. Let's see, where's port 1, port 2? Okay, so they're not up here. So we might have them configured differently. We'll take a look at that. Okay, so I'm going to go to the CLI here, escape, show run, see what our running configuration says. Okay, so FA01 and 2 are there, but they're not showing up in a VLAN. So there's all our 24 ports, our management interface, etc. Okay. So if I wanted to create a VLAN 1, go to the global config mode, config T, and I simply go, if I want to create a VLAN, let's say, I think I had VLAN 2 and 3 is what we were going to do. Let's just do VLAN 2. And then I can simply go name sales. And now Control Z, come back out, show VLAN. And we see that we have VLANs all in the same VLAN 1, but we now have a second VLAN. So how do I assign that if I want the interfaces? And I'm not sure what's going on here, why we don't have, let's just see here. Yeah, I thought so. I think the output is not exactly right because of being a simulator. Okay. So what I want to do is I want to put FA01 and FA02 into VLAN 2. I'm going to go config T int FA0. Actually, I can do an interface range. FA0/1 2, I think we can get away with that. No, I'm gonna have to go FA. Okay, so now I am in the interface range, so I'm configuring them both at the same time. And I'm going to go switch port, mode, access, and then switch port, access, VLAN 2. We'll see. Do a show VLAN. And now we see VLANs, FA01 and FA02 are in VLAN 2. Okay. All right. What I'm going to do next, excuse me, if I live through it, is I'm going to connect some cables. I'm going to put a straight through cable going FA03 down to the PC. And I'm going to go with a crossover cable 4 to FA04. And now we have a link between the two, and I want to make that a trunk. Well, it turns out that between two switches, it defaults to a trunk, which we really don't want, but we can end up getting that. Let's do a show in trunk and see if it did that. So it did. FA3, let's see here, in trunk, I mean, is trunking, well, that shouldn't be, FA03 should not be trunking. So what we're going to do is put FA03 into access in VLAN 2. So int FA0/3. This thing's behaving just a little bit weird. Okay, so then we do Control Z, show int trunk, and there we go. So FA04 is a trunk, but the problem is that it's in the desirable mode, and that's it's trying to negotiate with the other side. It's negotiated 802.1q is the encapsulation, but we want to put that FA04 into actually a trunk mode, and that way it won't have the desirable mode. It'll be actual trunking mode. So int FA0/4, and then switch port mode trunk. If you spell it right. Okay. Z, show int trunk. It's still a trunk, but now it's in the mode of trunking on encapsulation 802.1q, not negotiated 802.1q. And VLANs 1 and 2 are allowed across the trunk. Okay. So it's that simple to set up a trunk. And now the issue would be, though, can these guys communicate with these guys over here? Well, we go over to, let's go to the desktop and the command prompt, do an IP config. Okay, so this 172.16.1.21 is there, whereas over here, we should have the same subnet. .11, okay, but can I ping 172.16.1.21? I think that was the one that was over there. I can't ping it right now. And why would that be? Well, because on the other switch, they're in VLAN 1, but on this switch, they're in VLAN 2. So something from one VLAN will not be sent into the other VLAN. So what I'm going to do over here, CLI, and I'm going to put ports 1, 2, and 3 in VLAN 2, and then see if I'm able to communicate between the two. So go interface range FA0/1 dash FA0/3 and switchboard. Yes, switchboard mode access. Now, let's see what happens here, because I didn't create VLAN switchboard access. VLAN 2. I haven't created VLAN 2 over here, though. So it created it for me. Control Z. Show VLAN. Okay. The difference is that when I created it that way, it gave it the default name, but VLAN 2 should be named sales. So the way I would fix that, config T, VLAN 2, name, sales, enter, show VLAN, and now it's named sales. So now, however, I've got these ports here in VLAN 2. On the other side, they're in VLAN 2. Let's see if we can actually ping from one to the other. Ping 172.16.1.11. And yes, it now works. Okay. So that's what we want to understand, is that by putting all of these and all of these in the same VLAN, they could communicate across here. This is a trunk carrying VLANs 1 and 2 that are active on the trunk. It actually allows all VLANs across the trunk. Okay. So is there any question about any aspect of that? Just a second here. I'm going to get this real quick. Dave, I'm in class. I'll call later. I'll call you back. Bye-bye. Yeah. So this is a very basic configuration, and we haven't operated a VLAN VTP in this thing, but if we wanted to, let's go here. We can do a show VTP. Show VTP domain. Example. I'm sorry. Show VTP. Let's put a question mark. What's it looking for? It's looking for status right now. Okay. So there we go. The domain hasn't been set. So on switch 1, the status is that right there. It's a server. It has no domain name. So what we're going to do is go ahead and configure a VTP domain. And we'll put this into domain Cisco just for grins. So config T, VTP domain. And let's do Cisco. And by the way, it's case sensitive. So on the other switch, it has to be configured the same way as Cisco. Okay. This is a server. I'm going to go to the other side. Whoops. There we go. And show VTP status. Now it's possible for them to automatically, and it did, it automatically picked up the name across that link, but they're both servers. So now we'll go config T, VTP, let's just so VTP mode would be server, client. We won't deploy it. Now I'll show you. Okay, now that, once we're in client mode, let's try and go VLAN 3. And notice that we cannot create a VLAN. Let's go back over to the other side and create VLAN 3. Okay, we now have it. Control Z, show VLANs, and we have VLAN 3. Let's go back to this client switch. Control Z, show VLAN, and we have VLAN 3. So that's what VTP does for you. You get VLANs synchronized across switches. Okay, so the domain name must match. It's case sensitive. You can create VLANs, delete VLANs on the server, but not on the client. Okay. Any questions about what we've covered so far? This is, fairly basic stuff. Mentioned earlier that switches operate. I'm going to close this one down and get the other one open. Switches operate on layer 2 addresses. Show MAC address table is the command on this one. It changes from some switches to others. And here we've learned about these different, this address right here, dynamically out FA04. So that's a MAC address that came through. We learned that from the source MAC address. Okay. And that's the basics of switching in a nutshell. Any questions about that? Any question about Ethernet addresses, how a switch basically works, how VLANs work? VLAN is a broadcast domain and is also normally a subnet. How VTP works, how trunking works, and 802.1q. Okay. All right. Well, if there are no questions, I think what would be best is for you folks to take this scenario that I have and just build it to look just like what I did here, is to add VLANs, a VLAN 2, put all devices in VLAN 2 on one switch, go up to the other side. You can put all ports there in VLAN 2, or what you can do is start with VTP, create VLAN 2 using VTP, put it both in the same domain, and then you can create your VLANs only on one switch, watch them come to be created on the other switch. Okay, that could be our lab portion for tonight. Any of you have any question about doing that?
But I think most of us usually follow along with you.
So you're able to follow along, and it's all super cemented in right now. And no problem, right? I mean, that's fine if it is. I just, I'm not getting, as I go along, I can't see your faces. I can't, I don't hear anything. So I don't know if it's, all just like, oh, yep, or it's like, oh, what the heck did he just do?
Half and half. But I don't know if everybody, but I think, I don't know if everybody follows along with you. But I think
Okay.
so. I'm not sure.
Yes, I understand. Anybody have any questions? Anything you'd like to review about what we've just set up here? Okay. So that's all perfectly clear. Wow, that's great. So let me ask this. If let's say I wanted to manage switch 1 from PC 11 right now. Anybody see a problem with what I'd have to do to make that work so I could do it? Anybody have any idea?
What do you have to set up telnet, no?
I have to set up telnet, exactly, right? And let's look at what's going on here with switch one, and we'll see if we can explore some things. First of all, we don't have telnet set up, so let's set up telnet. We'll just get that config T and line VTY 0 space 4, and we're going to go password. In this case, I'm just going to lowercase Cisco. Login is already there, but let's just put that in. So now telnet is set up. Okay, so that's one thing. When you telnet, what protocol do you need to use in order to telnet from one machine to another? In other words, do you telnet just over Ethernet, or do you have to telnet over IP? Does you use IP addressing, right? So,
Yes.
so I do a show IP interfaces brief. Let's see if I have anything that has, I do not. So nothing right now is in, has an IP address. So there's nothing, there's no destination address to telnet to. So if I went to PC11 and tried to telnet to the switch, there would be no destination IP address I could telnet to. So I have to give the switch an IP address. And I do that on the interface VLAN. Well, in this case, I have a problem. VLAN 1 interface is in VLAN 1, but all my devices are in VLAN 2. How do I fix that? Well, here, let me show you. Config T, interface VLAN 2. It's a software interface. And it automatically changed its state to up. IP address 172.16.1.1. We'll just use that. 255.255.255.0. And let's just now do a show IP int brief and see what's going on. So look what happened. When I created interface VLAN 2, it automatically brought it up and then put VLAN 1 in an administratively down and down situation or position. So now switch 2's management interface is in VLAN 2, and that's its address. Now let's try and ping 172.16.1.11 would be the okay, that's the device out there. The other thing is, if I'm going to get into the enable mode on the switch, I have to have an enable password set. So I'm going to go config T, enable secret Cisco, enter. Okay, bingo. And now I'm going to open up, I'll close this. I'm going to open up PC11, go to the command prompt. And I'm going to telnet to 172.16.1.1. Password is Cisco, enable. Password is Cisco. And now I'm on the switch. But notice I had to put the management interface in the same VLAN as the devices. Now, why did I have to do that in this situation? Well, the reason is that if I'd left the management interface in VLAN 1, to get to VLAN 1 from VLAN 2, I have to go through a router, and there are no routers in this environment. Having the management interface in VLAN 1 would be fine, and having all the other devices in VLAN 2 would be fine as long as I had a router through which I could get to the switch. So because we didn't have a router here, I had to put the management interface in VLAN 2 in order to manage it from a device that was in VLAN 2. Okay. So that's how I would set that up. Now let's try this. Show CDP neighbors. Okay, so there's my neighbor, I only have the one neighbor, switch. He's out at my FA04 and I'm out his FA04. We're both 2960s switches. There's a version of this, show CDP neighbors star. I'm sorry, detail, not star. Okay, show CDP neighbors detail gives me now more information, but there is no IP information over there for, there's no IP address set, so it doesn't show me, but otherwise, if there was an IP address, it would show me that. But show CDP neighbors detail. You can also do show CDP entry star, and you'll get basically the same thing. So show CDP entry star and show CDP neighbors detail gives you the same readout. Okay. That's CDP. All right. Well, if there's not anything further for you folks to any questions that you have, I'm happy to, I'll just stay online and answer questions if anybody has questions.
Quick
And
question.
okay, go ahead.
So on the C prompt, you've used telnet and an IP address. Suppose you'd configured SSH instead of telnet, would you still be able to use that from the command prompt like you have on with telnet?
No, I would have to use SSH. I couldn't telnet if I configured this.
No, I'm asking. So you can still use SSH from the command prompt instead of CLI?
This command prompt would not support SSH.
Okay.
I think you'd have to use one of the little utilities that does support it.
Okay.
Yeah.
Thank you.
Mm-hmm. Okay. All right. No other questions. I'll tell you what, I'll just hang around here if anybody has any. Otherwise, while I'm hanging here waiting for questions, I'm going to go ahead and answer Armando's email, and I'm going to reply to everyone and send you out the slides that some of the slides I've been using, so folks can review with those slides. Okay. Otherwise, we're wrapped up for tonight, and I'm going to stop the sharing, and we'll go ahead and plan to meet Thursday night at same time, 6 o'clock.
Okay. Good night.
Good night. Take care.
Thank you, Gary.
Thank you.
Good night.
Take care. Good night.
Good night.
Good night.
Actually, before I go, sorry.
Sure, no worries.
When would you be doing subnetting? Because I took the CCNA exam last week and I failed.
Okay. Well, I'll tell you what, let's do subnetting next Thursday. Okay.
Okay.
That would be fine, because everybody needs to get into it, and it's a bear. It'll take a good evening to do. So
Yeah, because anytime I think I've got it, then I see a question and I'm confused all over again.
yeah, I like to teach. I've got some slides for subnetting, but I like to teach it with a whiteboard. And this whiteboard, of course, is a little bit burdensome, but we'll struggle through that.
Bye.
Bye-bye. Take care. Have a good night.
You too.